You are already moving at the fastest speed in the universe, right now, not through space but through time. And the moment you try to steal a little more speed through space, something strange happens. Time slows down, distances shrink, mass swells, reality itself pushes back. You can build a faster rocket, a stronger engine, a star-powered accelerator stretching across a galaxy. But no matter what you do, you will never reach the speed of light. Not because we lack technology, because the universe does not allow it. Somewhere, buried inside the mathematics of nature, there is a limit, a hard boundary. A number that does not negotiate, 299,792,158 meters per second. Light reaches it effortlessly. You never will. And when Richard Feynman stared into the equations describing light, he uncovered something far more disturbing than a cosmic speed cap. He realized the limit isn't about motion, it's about the structure of reality itself. The question isn't why can't you go faster? The question is, why does reality need a limit at all? For centuries, speed felt negotiable. Throw a rock, it moves faster than your hand. Fire a cannon, faster still. Build an engine, faster again. In the world of everyday life, speed simply adds up. If you run forward inside a moving train, you go faster than the train. That was common sense. Then light ruined everything. In the 1800s, physicists assumed light moved through a mysterious substance called the ether, a cosmic medium filling space. Earth should have been moving through this ether like a boat through water. That motion should have changed the measured speed of light depending on direction. It didn't, no matter how Earth moved, no matter the season, no matter the direction. Light's speed remained the same, identical, unwavering. That wasn't just surprising, it was catastrophic. Because if light's speed doesn't add like normal speeds, then space and time themselves must adjust to protect it. Enter Einstein, who declared that the speed of light is not just the speed of light, it is the speed of causality, the maximum rate at which information, influence or cause can travel. But that only deepened the mystery. Why would reality privilege one particular speed? Why that number? Why not faster? To answer that, we have to stop thinking of light as a beam racing through space, and start thinking of light as the stitching of space and time themselves. Imagine reality as a fabric, not metaphorically, literally structured with rules about how events connect. Every event has a light cone, a boundary defining what can influence it and what cannot. That boundary expands outward at exactly the speed of light. Nothing can cross it. If something did, it wouldn't just move fast. It would break causality. Effect could precede cause. Messages could arrive before they're sent. You could warn your past self. The universe would unravel into paradox. So the limit isn't arbitrary. It's the firewall protecting logical order. But Feynman pushed deeper. He asked a different question. Why does light move at that speed specifically? In quantum electrodynamics, the theory describing how light and matter interact, light is not just a wave. It's a particle, a photon, massless. And here's the key. Particles with mass can never reach light speed because as they accelerate, their energy increases. That energy increases their relativistic mass. The closer they approach light speed, the more energy is required for even a tiny boost. Approach the limit, and the required energy approaches infinity. To reach light speed, you would need infinite energy. Not a lot. Infinite. Which means the barrier isn't technological. It's mathematical. But photons are different. They have no rest mass. And here is the shock. They do not accelerate to light speed. They are born moving at light speed. There is no photon at rest. There cannot be. The equations don't allow it. And that suggests something radical. Light speed is not a velocity light happens to have. It is the conversion rate between space and time. 1 second of time equals 299,792,458 meters of space. That's not motion. That's geometry. Space and time are fused into spacetime, and light speed is the angle at which they tilt into each other. If you move through space, you move less through time. If you move through time, you move less through space. And everyone always moves through spacetime at the same total speed. Light simply allocates all of its motion through space. You allocate most of yours through time. That's the hidden symmetry. And suddenly the limit stops feeling like a rule imposed from outside. It feels like a structural property. Like asking why the angles of a triangle add to 180 degrees. They just do because of the geometry. But geometry of what? Here is where things escalate. Quantum field theory, the framework Feynman helped build, describes reality not as particles floating in empty space, but as fields extending everywhere. The electromagnetic field, the electron field, the quark field. What we call a particle is just a vibration in its field, a localized ripple, and those ripples interact according to strict mathematical symmetries. One of those symmetries is Lorentz invariance, the rule that the laws of physics must look the same for observers moving at constant speeds relative to one another. That symmetry mathematically requires a maximum invariant speed. Remove it, and the equations collapse. Change it, and you rewrite causality. The speed of light isn't just about light. It's baked into the symmetry of the fields themselves. Feynman once described how a photon explores every possible path between 2 points. Not just the straight line, every zigzag, every loop, every impossible trajectory. Each path contributes a tiny amplitude. Add them together, and the dominant contribution aligns with the path that corresponds to light speed. In a sense, light doesn't choose the fastest path. It chooses the path consistent with the structure of spacetime. And all other paths cancel out. That's not classical motion. That's quantum orchestration. Now pause, because here's the conceptual shock. If light defines the structure of spacetime, and spacetime defines causality, then the speed limit is not imposed on reality. It is reality. The limit is the scaffolding. Remove it, and space and time no longer fit together coherently. But let's push further. Imagine you somehow exceed light speed. From some observer's perspective, your arrival would precede your departure. In special relativity, time order depends on relative motion for events separated faster than light. So superluminal travel doesn't just mean really fast. It means time can flip, cause and effect can reverse. And if cause and effect reverse, the predictive structure of physics dissolves. The universe becomes inconsistent, a contradiction engine. The speed limit is not a ceiling, it's a consistency condition. And yet, quantum mechanics teases us. Entangled particles influence correlations instantaneously across vast distances. Measure one here, and the other responds there. Faster than light? Not quite. No usable information travels. The correlations obey the light speed limit for signals, but they hint at something deeper, a layer of reality where space-time itself may not be fundamental, which raises a terrifying possibility. What if light speed is not the ultimate limit? What if it's the limit inside? Space-time is emergent. Some theories of quantum gravity suggest space-time arises from deeper entanglement networks. If so, the speed of light would be like the maximum speed inside a simulation, a property of the rendering engine. Not absolute, just foundational to this layer. But even then, the limit remains sacred within the structure we inhabit. And that brings us back to you. You are not prevented from reaching light speed because the universe is cruel. You are prevented because you are made of mass. You are a knot in quantum fields. And mass is resistance to changing how you move through space-time. To move faster through space, you must rotate your trajectory away from time. As you do, time slows for you. Clocks tick differently. Lengths contract. Energy swells. The universe bends to protect its invariant speed, not violently, elegantly. Every equation conspires to keep that number untouched. Light speed is the silent referee of reality. But here is the final twist. From the photon's perspective, if such a perspective existed, there is no time. A photon emitted from a distant galaxy billions of light-years away and absorbed in your eye experiences no passage of time. Emission and absorption are the same event. For light, the universe has zero duration. The entire cosmic journey is instantaneous, which means that what feels like billions of years to you is nothing to light, and that reframes everything. The speed limit doesn't just constrain motion, it's experience. It defines how time flows differently for different beings. It determines how the universe ages. It ensures that no information outruns consequence. And maybe, just maybe, it tells us something about why reality is stable enough for you to exist at all. Because without that limit, stars couldn't burn predictably. Atoms couldn't hold structure. Causality couldn't chain events into complexity. Life would not assemble. The limit isn't restrictive, it's generative. It's the boundary condition that allows order. And now we return to the beginning. You are moving at the fastest speed in the universe, always, through spacetime. You can redistribute that motion, trade time for space, but you cannot exceed the total. The universe doesn't forbid you from outrunning light. It defines you in a way that makes it impossible. And Feynman's deeper insight was not that light is fast. It's that the laws of physics are built on symmetries so rigid, so mathematically intertwined, that the limit emerges inevitably, not as a decree, as a necessity. So the next time you look at a beam of sunlight cutting through dust, remember, you are watching the edge of causality, the stitching of space and time, the maximum slope reality allows between here and elsewhere. And somewhere in the equations humming beneath existence, that number stands untouched, not because it can't be broken, but because breaking it would mean there is no before, no after, no story, and without a story, but without cause leading to effect, there would be no you, wondering why the universe refuses to go any faster. If the speed of light is the boundary of causality, then Chapter 1 only showed you the fence. Now we have to walk up to it, not from the outside, but from inside the machinery of reality itself. Because the real shock isn't that nothing outruns light. The real shock is why the universe needs that limit to exist in the first place. Close your eyes and imagine stripping the universe down to its skeleton. No stars, no galaxies, no planets, no atoms, just fields. According to quantum field theory, the framework that reshaped physics in the 20th century, reality is not made of tiny billiard ball particles flying through emptiness. There is no emptiness. There are only fields stretching everywhere. The electron field fills the cosmos. The quark field hums beneath it. The electromagnetic field vibrates invisibly through every cubic centimeter of space. What we call a particle is just a ripple in one of these fields, a localized vibration, a note played on an infinite instrument. And here is the first escalation. These fields are not optional decorations. They are constrained by deep mathematical symmetries. One of those symmetries is Lorentz invariance, the rule that the laws of physics must look identical for observers moving at constant velocities relative to one another. If I drift past you in a spaceship at 10% the speed of light, or 90% the equations describing, electromagnetism must still work. The fields cannot prefer one constant speed over another, except one. There must be a universal invariant, a speed that remains the same for all observers. Without it, transformations between moving frames would distort the laws of physics into contradictions. That invariant speed emerges from the structure of spacetime itself, and it turns out to be exactly the speed light travels. But notice what just happened. Light did not set the speed limit. The symmetry of spacetime demanded it. Light merely revealed it. Now let's deepen this. Maxwell's equations, written down in the 1860s, describe how electric and magnetic fields oscillate and propagate. When you solve them, a wave naturally appears. That wave moves at a speed determined by two constants, the electric permittivity and magnetic permeability of free space. Crunch the numbers and you get 299,792 thoso, 458 meters per second. Before Einstein, before relativity, the equations themselves were whispering, there is something special about this speed. But here's where tension rises. If you were chasing that electromagnetic wave at near light speed, classical intuition says you should see it slow down, like catching up to a moving ripple on water. But Maxwell's equations refuse to allow that. The wave's speed doesn't care how fast you chase it. It remains fixed, unchanged. And that mathematical stubbornness forced Einstein's radical conclusion: space and time must bend to preserve the symmetry of fields. Length contraction, time dilation, relativity of simultaneity, all of it emerges from protecting that invariant speed. But Feynman wasn't satisfied with surface explanations. He wanted to know how nature actually calculates. In quantum electrodynamics, light interacting with matter is described through probability amplitudes. Tiny arrows in complex space, spinning and combining. When a photon travels from point A to point B, it doesn't take one path. It takes every path. Every possible trajectory contributes. Some paths reinforce each other, most cancel out, and the dominant contribution aligns with the classical path, the one consistent with light speed. Here's the shock. The reason we observe a sharp, definite light speed limit is because all other possibilities interfere destructively. Reality self-organizes. Paths that would imply superluminal propagation don't accumulate coherent probability. They mathematically erase themselves. It's not that the universe blocks faster-than-light travel like a police officer stopping traffic. It's that the quantum amplitudes refuse to cooperate. They don't add up. They cancel into silence. Now let's escalate further. Imagine tweaking the universe. Change that invariant speed, make it twice as large, or half. What happens? Atoms change size. The strength of electromagnetic interactions shifts. The fine structure constant, the dimensionless number controlling how electrons bind to nuclei would alter. Stars might be burned too quickly, or not ignite at all. Chemistry could collapse. Complex molecules might never form. In other words, the speed of light isn't just about motion. It regulates the architecture of matter. It defines how tightly electrons orbit nuclei. It determines how quickly electromagnetic signals propagate within atoms. It sets the pace at which stars fuse hydrogen into helium. It shapes the entire evolutionary ladder from plasma to consciousness. The limit is woven into existence at every scale. And now we reach a conceptual cliff. In relativity, the speed of light is also the slope of spacetime's light cone. Every event has a future light cone, the region it can influence, and a past light cone, the region that can influence it. Everything outside those cones is causally disconnected. But if faster-than-light motion were possible, those cones would tip. Different observers would disagree about which event came first. One observer sees cause, then effect. Another sees effect, then cause. And because relativity allows continuous transformations between frames, you could create closed time-like loops. Send a message to the past, prevent its own sending. Logical contradiction. The universe would contain events that both happen and don't happen. Physics would not merely become unpredictable, it would become inconsistent. That's deeper than chaos. It's structural collapse. The speed limit prevents that collapse. It enforces a consistent ordering of influence. It protects the and now something even stranger. Gravity also obeys this limit. In general relativity, space-time curvature propagates at light speed. If the sun vanished instantly, Earth would not fly off immediately. It would continue orbiting for about 8 minutes, the time it takes gravitational influence to reach us. Even gravity bows to the invariant speed, which suggests that the limit is not electromagnetic, it is universal. It is stitched into spacetime's geometry at the deepest level we understand. But here is where tension builds again. Quantum entanglement seems to laugh at this limit. Two particles interact, then separate by light years. Measure one, and the state of the other is instantly correlated. No signal appears to travel between them. Einstein called it spooky action at a distance. Yet no usable information travels faster than light. The correlations are real, but they cannot be exploited to send messages. Causality remains intact. The speed limit survives. And that survival is not trivial. It hints that even quantum weirdness respects the deep consistency of spacetime. Now, let's zoom out. The observable universe is 93 billion light-years across. Why light-years? Because light defines distance. It defines the maximum horizon. When we say something is 13 billion light-years away, we're measuring not just space but the maximum possible travel time of information since the Big Bang. Light speed sets the size of what can be known. It shapes the boundary of the observable cosmos. Without that limit, the concept of a horizon dissolves. There would be no meaningful distinction between observable and beyond. Information could arrive from anywhere instantly. Structure would lose locality. And locality, the idea that objects influence nearby regions first, is foundational to physics. It allows complex systems to evolve step by step. It prevents the universe from becoming an instantaneous blur. Now return to yourself. Your neurons fire via electrochemical signals limited by electromagnetic propagation. Your thoughts cascade at finite speeds. Your perception of time is structured by signals traveling across tiny distances inside your skull. Even consciousness operates within the cosmic speed limit. You are a local process unfolding causally. If signals inside your brain traveled infinitely fast, there would be no sequence of thought, no narrative continuity. Experience itself might fracture. The limit is not only cosmic, it is cognitive. And here's the unsettling insight: the speed of light might not be about light at all. It might be about information, about how quickly correlations can form, about how fast reality can update itself. Some physicists propose that spacetime emerges from quantum entanglement networks, a vast web of information relations. If so, the speed of light could represent the maximum rate at which information reorganizes within that network, a bandwidth cap on existence, not imposed from above, but emergent from below. If that's true, then breaking the light speed limit would require rewriting the information processing rules of the universe, not building a faster engine, reprogramming reality. And that brings us to a deeper tension. We treat the speed of light as a barrier, but maybe it's more like a conversion factor. Just as temperature measures average kinetic energy, light speed measures how space converts into time. In relativistic geometry, moving faster through space reduces your movement through time. At light speed, time stops, which means the limit is tied to the existence of time itself. Push beyond it, and time would have to become imaginary, literally complex valued in the mathematics. That's not poetic, that's what the equations imply. Beyond light speed, intervals flip sign. Temporal separation becomes spatial. The structure of space-time changes category. You would not simply move faster. You would enter a regime where the meaning of before and after dissolves. So maybe the better question isn't, why can't you go faster than light? Maybe it's, why does time exist in a way that requires this limit? And if time is tied to entropy, to the growth of disorder, then the speed limit might be entangled with thermodynamics itself, the arrow of time, the irreversibility of experience, the fact that you remember the past but not the future. All of it rests on causal structure, and causal structure rests on the invariant speed. This is no longer about it's about existence being stable enough to unfold. The universe chose consistency over chaos, geometry over paradox, finite propagation over instantaneous confusion. And as we approach the edge of this chapter, something unsettling remains. Every law we know respects the speed of light. Every successful experiment confirms it. But our deepest theories, quantum gravity, string theory, emergent spacetime models, hint that spacetime itself might not be fundamental. If spacetime emerges from something deeper, then the speed of light is a property of the emergent layer, like the speed of sound in air, fundamental to the medium, but not necessarily fundamental to ultimate reality. And that possibility cracks open the next escalation. Because if light speed is the limit inside spacetime, what happens outside it? What lies beneath the geometry that enforces this sacred number? And if spacetime is not the bedrock, then the speed of light is not the wall. It's the shadow of something deeper. And this is where the ground begins to disappear beneath your feet. For everything we've said so far, relativity, causality, Lorentz symmetry assumes spacetime is the stage on which reality unfolds. A smooth, four-dimensional arena where events sit at coordinates, where light cones carve order into chaos. But what if spacetime is not the stage? What if it's the projection? Over the past few decades, theoretical physics has been circling a radical possibility. Spacetime might be emergent, not fundamental, not primary, but something that arises from a deeper, pre-geometric layer of information. In some approaches to quantum gravity loop, quantum gravity, holographic dualities, entanglement-based models, geometry itself appears to grow out of patterns of quantum entanglement. Connections first, distance later. In these models, space is not a container, it is a network. And distance between 2 points is not measured by meters, but by how entangled their underlying quantum states are. More entanglement? Closer in space. Less entanglement? Farther apart. If that's true, then the smooth geometry of spacetime with its invariant light speed is like a large-scale illusion emerging from microscopic quantum links. Now pause, because if spacetime emerges from entanglement, Then the speed of light might be the maximum rate at which entanglement patterns can reorganize, a processing limit, a cosmic refresh rate. Imagine reality as an unimaginably vast computational network, not a simulation in the sci-fi sense, but a physical system whose deepest description is informational. In that picture, the speed of light would be the maximum speed at which information can propagate across the network without breaking consistency. Go faster, and updates would overlap, states would conflict, logical contradictions would ripple through the system. Sound familiar? It's the same causal collapse we encountered earlier, just reframed at a per layer. The limit persists. But now it looks less like a geometric rule and more like an informational constraint, and that is haunting. Because information is not abstract, information is physical. As Landauer taught us, erasing information has thermodynamic cost. Computation requires energy. Entropy governs memory. So if the speed of light caps information flow, then it also caps how quickly entropy can rearrange, which ties the cosmic speed limit directly to the arrow of time. You experience time flowing forward because entropy increases. Disorder grows. Information about microscopic details spreads and becomes inaccessible. And how does that information spread? At finite speed. If influence were instantaneous, entropy would equilibrate instantly. The universe would collapse into thermal sameness in a blink. No structure, no stars, no evolution, no you. The speed limit allows complexity to unfold gradually. It gives the cosmos room to breathe. Now zoom out. At the beginning of the universe, at the Big Bang, space-time itself was compressed into a hot, dense state. Distances tiny, energies enormous. As the universe expanded, light carried information outward, defining causal regions. Some regions never had time to influence one another, their light cones never overlapped. That's why the observable universe has a horizon. But here's the twist. Inflation theory proposes that in the earliest fraction of a second, space expanded faster than light, not objects moving, through space faster than light, space itself stretching. And that distinction is everything. Because relativity forbids motion through spacetime faster than light, it does not forbid spacetime itself from expanding. Galaxies today can recede from us faster than light due to cosmic expansion, and yet no local law is violated. The limit survives locally. Causality remains intact. The deeper message. The speed of light governs relationships within spacetime, not the global evolution of spacetime itself. So even the apparent exceptions protect the rule. Now let's return to the photon. Earlier we said that from the photon's perspective, no time passes between emission and absorption. Strictly speaking, photons do not have valid rest frames in relativity, but mathematically, as velocity approaches light speed, time dilation becomes extreme. At light speed, proper time collapses to zero, which implies something extraordinary. For light, the universe has no duration. Emission and absorption are adjacent in its own null trajectory. Billions of years for you. No time at all for it. That is not just a curiosity. It hints that light occupies a boundary state between space and time, not fully temporal, not purely spatial. The invariant speed is the seam between these categories, and here comes the final escalation. If light speed is the conversion factor between space and time, then exceeding it would not simply mean going faster. It would require redefining the categories. Themselves, beyond light speed, intervals become space-like, causality fractures. Time becomes mathematically imaginary in the metric. You don't get superspeed. You get a different kind of geometry, a different ontology. In some speculative theories, hypothetical particles called tachyons were proposed entities that always move faster than light. They would never slow down below the limit, but introducing them destabilizes quantum field theories. Energies become unbounded below. Vacuums become unstable. Reality refuses to host them. Again and again, the mathematics self-corrects. It protects the boundary. Now step back and look at the pattern. Every time physicists try to violate the light speed limit, the equations respond with infinities, instabilities, contradictions, or category shifts. It's as if the limit is not a speed at all. It's a phase transition boundary. On one side, causal, time-ordered, entropy-growing spacetime. On the other, undefined structure. The known dissolves. And here is the quiet intellectual shock. The speed of light may not be telling us how fast things can move. It may be telling us what kind of universe we inhabit. A universe where cause precedes effect, where information spreads gradually, where complexity has time to assemble, where memory can form, where evolution can proceed, where consciousness can arise and ask questions. If influence were infinite, reality would be instantaneous, and instantaneity leaves no room for narrative, no tension, no story. The cosmic speed limit is what makes stories possible, including yours. And now we return to Feynman. He once said that nature's imagination is so much greater than ours. When he developed the path integral formulation, he showed that particles explore all possible histories, but only certain histories constructively interfere to form the classical world we observe. Out of infinite possibility, coherence emerges. Light speed is part of that coherence. It is the constraint that allows quantum chaos to condense into classical order. Without it, amplitudes wouldn't settle into stable patterns. The macroscopic world might never crystallize. The limit is not a restriction imposed on freedom. It is the rule that allows freedom to have structure. And now we reach the reflective edge. You cannot outrun light, not because you are weak, not because technology is insufficient, but because you are a pattern inside a causal network that defines itself through that invariant speed. You are made of fields obeying symmetries that demand it. You are a story unfolding at finite bandwidth, and the fact that there is a limit, a number carved into the fabric of reality, is the reason the universe does not collapse into paradox, the reason stars burn instead of explode unpredictably, the reason atoms hold their shape, the reason your past stays behind you, the reason your future has not happened yet. The speed of light is not the enemy of ambition, it is the difference. And perhaps the most astonishing realization is this. The universe did not choose the fastest possible structure, it chose the most consistent one. A cosmos where information propagates just slowly enough to build galaxies, just slowly enough to build brains, just slowly enough for you to sit here, inside a fragile bubble of causality, wondering why you cannot go any faster. You are not trapped beneath the limit, you are protected by it. Because if you could outrun light, you would outrun cause. You would outrun time. You would outrun the very chain of events that led to you existing, and then there would be no you left to cross the line. The limit remains, silent, unbroken. Not as a wall in front of you, but as the invisible structure that allows reality to hold together long enough for you to ask why it does. And yet, even after everything, relativity, quantum fields, causality, information, one question still hums underneath the silence. Why this number? Why 299,792,058 meters per second? Why not slightly faster? Slightly slower? Why does the universe lock onto this precise value with such ruthless consistency? At first glance, the number looks arbitrary, human, artificial. But that's because meters and seconds are human inventions. Strip those away. Use natural units, the kind physicists prefer when they want to see the bones of reality, and something strange happens. The speed of light becomes one, not big, not small, just one, because in the best equations of physics, space and time are measured in the same currency. Light speed is simply the exchange rate that converts one into the other. It's not that light is moving at some cosmic velocity, it's that space-time is calibrated around that slope. And when you rewrite the laws of physics in their most fundamental form, the speed of light disappears as a dramatic number and becomes a structural constant, a symmetry marker, a boundary condition, which suggests something unsettling. Maybe asking why this number is like asking why a circle has 360 degrees. It's not imposed, it's intrinsic to the geometry. But here's where the ground shifts again. There are other constants woven into the universe. Planck's constant, the gravitational constant, the fine structure constant. Together, they define the Planck scale, the regime where quantum mechanics and gravity collide. At the Planck length, space-time itself may lose smoothness. At the Planck time, the very notion of before and after might dissolve into quantum foam. And when you combine those constants, the speed of light appears again not as an isolated rule, but as part of a deeper triad controlling how energy, space, and time interrelate. This is where speculation turns into vertigo. Some physicists wonder whether these constants could have been different in other possible universes. If the speed of light were larger, electromagnetic forces would weaken, atoms would swell, chemistry would shift. If it were smaller, forces would tighten. Stellar processes would change, lifetimes of stars would shorten. Tiny adjustments ripple outward, structure teeters. And so the limit that once seemed restrictive begins to look tuned, not necessarily by design, but by stability. Perhaps only certain values allow a universe to avoid immediate collapse into chaos or stagnation, and ours sits on that narrow ridge, balanced, precarious. Now consider something even more disorienting: black holes. At the event horizon of a black hole, the escape velocity equals the speed of light. Cross that boundary, and not even light can return. But notice what that implies. The speed limit is not merely a restriction on objects. It defines the architecture of gravity itself. The event horizon is drawn precisely where space-time curvature forces light cones to tip inward. Beyond that line, all possible futures lead deeper into the singularity. The speed of light shapes not only motion but destiny. Inside a black hole, space and time swap roles. The singularity lies in your future the way tomorrow lies in yours. You cannot avoid it. And again, the invariant speed determines that structure. It is the silent line between escape and inevitability. Now imagine pushing physics further. Suppose one day we discover that space-time truly is emergent, arising from quantum entanglement patterns described by some deeper theory. Would the speed of light then dissolve? Or would it reappear as the emergent property of that? A layer like the speed of sound emerges from molecular interactions in air. If space-time is like a fluid, then light speed is its stiffness, its elasticity, its maximum signaling velocity. In that case, breaking the speed of light wouldn't mean upgrading a spaceship. It would mean changing the medium of reality itself. And that may be impossible not because it's forbidden, but because there is no outside medium to switch to. This is the conceptual edge. The speed limit may not be something inside the universe. It may be what makes a universe possible at all. Without a maximum signal speed, locality vanishes. Without locality, independent regions cannot evolve semi-autonomously. Without semi-autonomy, complexity cannot scale. Without scaling, galaxies don't assemble. Without galaxies, stars don't form. Without stars, heavy elements don't exist. Without heavy elements, chemistry cannot bloom. Without chemistry, biology never ignites. Without biology, there is no mind. And without mind, there is no question. So the limit that frustrates our dreams of warp drives might be the same limit that allows dreaming in the first place. Now, return to yourself. You are not a spectator of this cosmic boundary. You are built from it. Every atom in your body obeys electromagnetic interactions governed by that invariant speed. Every thought arises from neurons exchanging signals at velocities capped by it. Your memories unfold sequentially because information cannot propagate infinitely fast inside your brain. If signals were instantaneous, your entire life would collapse into a single frozen moment, no sequence, no narrative, no growth. The speed of light stretches experience across time. It gives life rhythm. And here, quietly, is the final revelation. We began by asking why light speed is the limit. But maybe that question is inverted. Maybe the real question is, why does reality have a structure that requires limits at all? Because limits define form. Without boundaries, there is no shape. Without maximums, there is no gradient. Without gradients, there is no motion. The invariant speed is the sharpest boundary in physics, the place where geometry, causality, and information converge. It is not merely the fastest something can go. It is the line separating what can influence from what cannot, the line separating possible from forbidden, the line separating coherence from contradiction. And perhaps the most humbling realization is this: we may never step beyond it, not because we lack ingenuity, but because stepping beyond it would mean stepping outside the very framework that defines existence. You cannot outrun light because you are a configuration of space-time. Trying to exceed it would be like a ripple trying to outrun the water that defines it. The ripple can move, it can change shape, but it cannot leave the medium, and so the limit stands, not as a prison wall, but as the deepest structural truth we have ever uncovered, a quiet number, embedded in equations, a slope drawn through spacetime, a boundary protecting cause from collapsing into chaos. You are moving through spacetime right now at the only speed any massive thing ever can, trading motion through time for motion through space, redistributing but never exceeding. And somewhere at the heart of reality, that invariant speed hums not loudly, not dramatically, just steadily, holding the universe together, holding your story together, ensuring that before remains before, after remains after, and that between those two fragile words there is just enough room. And now we arrive at the edge, not the edge of space, not the edge of technology, but the edge of understanding, because after everything relativity, quantum fields, black holes, entanglement, emergence, one final tension remains. If the speed of light is so deeply woven into reality, why does it feel like a barrier to us at all? Why does the universe allow us to imagine exceeding it? Why does it tempt us with the possibility? The answer may be more psychological than physical. You evolved in a slow world, a world where speeds add, where you can throw faster, run faster, build faster, where limits feel like challenges waiting to be broken. So when you encounter a number that refuses to budge, a cosmic ceiling that doesn't negotiate, it feels like an insult to ingenuity. But the light speed limit is not a technological wall. It is a geometric fact, and geometry does not yield to ambition. You can no more exceed light speed than you can draw a triangle with 4 sides. The frustration arises because we confuse motion with freedom. But in physics, freedom is constrained by symmetry, and symmetry is not restriction, it is consistency. Now let's zoom all the way out. Imagine a universe with no maximum speed. Information propagates instantly. Every event influences every other event immediately. No delays, no horizons, no separation. At first, that sounds powerful, but think carefully. If influence is instantaneous, then locality disappears. If locality disappears, then independent structures cannot form. If everything affects everything immediately, nothing can differentiate. The universe would behave like a single, undivided blur. No stars forming here while galaxies collide there. No evolutionary branches, no gradual assembly of complexity. Just a homogeneous instant, a frozen totality. Paradoxically, slowness creates structure. Finiteness creates diversity. The speed of light carves the universe into regions that can develop their own histories before interacting with others. It gives the cosmos time to experiment, time to fail, time to evolve. And this is where the realization becomes almost philosophical. The limit is not just about speed, it's about separation. And separation is what allows identity. You exist because you are not instantly merged with everything else. Your thoughts occur sequentially because signals in your brain take measurable time to. Your memories line up in order because cause cannot overtake effect. The speed limit protects narrative, and narrative is what makes experience meaningful. Now let's confront one last idea. Suppose in some distant future, humanity masters space-time engineering, wormholes, warp metrics, curved geometries that bend the path between 2 points. Even then, locally, nothing outruns light. The trick would not be exceeding the limit. It would be reshaping the geometry so the limit still holds, but the path changes. That detail matters, because it reveals something profound. The universe does not prohibit creativity. It prohibits contradiction. As long as causality remains intact, the cosmic rulebook allows astonishing possibilities. But the invariant speed remains untouched, guarded not by force but by logic. And here is the final intellectual shock. The speed of light might not be the ultimate limit of reality, but it is the ultimate limit of causally ordered experience. Beyond it lies a regime where before and after lose stable meaning, where events cannot be arranged into coherent stories, where memory and prediction collapse. You cannot cross that boundary and remain a being who experiences time. You would dissolve into a different kind of description, one our current language cannot even frame. So perhaps the real reason you cannot outrun light is because outrunning it would mean outrunning the structure that makes you a self. You are not merely prevented from crossing the limit. You are defined by it. Every heartbeat, every sunrise, every second you feel pass. All of it depends on a universe where information travels at finite speed, a universe where light defines the slope of reality. And so we return to the paradox that began this journey. You are always moving at the maximum possible speed through spacetime. Always. You can redistribute that motion, lean harder into space, steal a little from time, but the total never changes. The invariant speed remains, silent, unbroken, unimpressed by rockets or dreams. Not because it crushes possibility, but because it is the condition that makes possibility coherent. The speed of light is not the enemy of progress. It is the grammar of existence. It ensures that causes lead to effects, that futures are open but not contradictory, that complexity unfolds instead of exploding into chaos. And perhaps, one day we will uncover a deeper layer beneath spacetime, a more fundamental architecture from which this limit emerges. But even then, whatever replaces it will carry its own invariant structure, its own consistency condition, because without a boundary there is no form, without form there is no universe. And without a universe ordered by cause and effect, there would be no moment like this one, no mind tracing equations across centuries, no photon crossing billions of light years to meet your eye, no question echoing in your thoughts. The cosmic speed limit does not trap you inside a small world. It holds the world together long enough for it to become vast, and in that vastness, under a sky stitched by light traveling at its sacred, unbreakable pace, you sit, bound by the limit, protected by the limit, defined by the limit, wondering why reality refuses to go any faster. And the quiet answer, humming beneath the stars, is this: because if it did, there would be no before, no after, no story at all.